Hello everyone, I am FutureiAI. In this class, we will explain the details about training samples. To demonstrate how to iterate on our private dataset for fire detection model training, we can use the FAST dataset from the Chinese Academy of Science as Scientific Data Bank website. This dataset is relatively new and was updated in August 2022. The specific download link is here. Here's an overview of the dataset. FAST contains 101,087 images, including 59,177 positive images, containing 82,666 flame objects and 57,740 smoke objects, and 41,910 negative images containing over 60 types of similar, but non-fire and non-smoke images. The entire FAST is composed of two sub-datasets, FAST_CV with 95,314 general computer vision images, and FAST_RS with 5,773 remote sensing images. Fire and smoke objects in FAST are labeled with the target detection task labels fire and smoke respectively. FAST provides for types of annotation files, OGG standard format, Pascal VOC format, Microsoft COCO format, yellow text format. After reviewing the dataset's description, we can confidently conclude that this dataset is suitable for training an initial model. The dataset provides an adequate amount of data and the label formats meet the requirements. We downloaded the CV version of FAST_CV, which consists of 12 gigabytes and 95,000 images. After unzipping the files, we found two directories, images containing all the photos and annotations containing for different types of annotations. Upon exploring the VOC directory, we observe that each image has an XML file with the same name, representing the image's annotations. Opening one of these XML files reveals information, such as the image name, resolution, and details about the detection boxes for flames and smoke. For instance, there is an indication of a flame detection box with its coordinates and a smoke detection box with its coordinates. The content of the other annotation files is quite similar, with the primary difference being the file format. This diversity in annotation formats allows for compatibility with various popular object detection frameworks, making FAST a versatile and convenient dataset for fire and smoke detection tasks. Next, we will proceed with creating our dataset. We'll start by creating a test set, which is used to evaluate the model's performance. This is similar to creating a test paper. For assessment, the data in the test set cannot overlap with the training data, and the data distribution should be comprehensive. Here I will create a directory with an arbitrary name, such as Evil, and then create two subdirectories inside it named Images and GT. The names are specific and must match to successfully import the data. For the FAST_CV dataset, the images are divided into 4 categories. Images with both smoke and fire, images with only fire, images with only smoke, and images with neither. I have selected a random sample of images from each category, ranging from 50 to 150 images per category, and place them in the images directory. The proportion distribution is mainly based on the original data distribution of the images. As I am more concerned about positive samples, I have slightly increased the number of images with both smoke and fire. You can adjust the proportion according to your specific requirements or by annotating actual scene images and adding them to the test set. Finally, I have placed the corresponding XML files annotations in the GT directory and compressed this directory into a zip file following the required format. I have used the same method to create a training set by selecting only 12 for the data, which includes over 8,000 images. Although larger datasets generally lead to better model performance, the improvement is not strictly linear with the number of images. Having too many similar images does not effectively improve model performance. However, the computational cost of each iteration is strictly linear with the number of images. If the dataset is too large, the performance may improve by a small margin, but the efficiency of each iteration will decrease. Therefore, it is important to strike a balance when selecting the appropriate dataset size for practical applications. Then we can start training the initial model. After several hours, the initial model will be trained and can be used for demonstration purposes. However, if we want to apply it in real scenarios, we may encounter some issues. If you take a clear look at the images in the FAST dataset, you will notice that the quality of the negative samples is relatively poor. Specifically, there are not many objects that neither contain smoke nor fire. In fact, there are only 60 types of objects that are very similar to smoke or fire. Therefore, the model's detection performance for real smoke and fire is satisfactory. But for cases that are not smoke or fire, there may be some false positives. We need to add more confusing false positive images to improve the model's performance. To reduce false positives, we need to add high-quality negative samples. In terms of specific operations, we need to leverage our relationship with the client.